All right. You can quite plainly see that solving by substitution is so easy that I've just written out everything in steps. That's how easy this is, because again, there is nothing new for you. We're going to highlight them in different colors, and we're going to work them in different colors. So step 1. It says to choose one of the equations that has a 1 that you can solve for one variable. And then I even give you a hint. Choose a letter that has a coefficient of 1. So you have two equations there. Which one should we work with? The top one. So I'm going to highlight it in yellow because we're going to use that because it's got the coefficient of 1. So that is step 1. Everybody agree we've chosen our equation? Great. What does step 2 say? We chose and we have to solve for one variable. What does that mean? Solve for x. What does that mean? What will it look like? Get x by itself. So to finish this yellow step, we need to get x by itself. So let's do that. We will keep working in red. What do I have to do to this equation to get x by itself? Nick, I got to move the 4y. So x is going to equal, what happens to 4y when he moves over? Positive 4y minus 1. Is everybody cool with that? All right. Now, what does this say? Read this to me in English. What does this whole thing say? Starting from there. X equals 4y minus 1. What does equals mean in English? Equivalent. The same. Something like that, yes? So this is technically saying that x is 4y minus 1, correct? That's what that says, right? Everyone agree? Okay. Step 2 says take the new equation. Do we have a new equation? What is it? X equals 4y minus 1. That's a new equation. We haven't seen that. That wasn't written on the page, was it? We made that equation, didn't we? Now, what does it say to do for that? It says substitute it into the other equation. Now, look at the other equation. What does it have? An x and a y. What do we know about x's now? They're 4y minus 1. So, is that x useful to us anymore? No, because it's not x. X is what? 4y minus 1. So we are going to take that and we are going to sub it into the new equation. 3, but it is not x. What is it? 4y minus 1. Plus what? 5y equals what? 31. Is everybody cool? It'll show up in a sec. It'll show up in a sec. It'll show up in a sec. Now, is that all still part of the blue step? We took the new equation, we substituted it into the other equation. Is that all blue step? Excellent. All blue step there, right? Now what? Green step, what does it say to do? Solve for the remaining variable. What is the only variable we have left, Jack? Y. So we take this and we get y. How do I get rid of these brackets? Expand to get what? Equals 31. Have I solved for y yet? What should I do now? Okay, I got 2 y's here. What do I got to do? Collect like terms. What is 12 y's and 5 more y's? Minus 3 equals 31. Now what? Get rid of the 3. 17y now equals what? 34. Now what? Divide by 17 to get what? Y equals 2. That is the green step. I have one more step to go. Let's highlight it in orange. Plug your solution in to the one of the original equations. Well, how many equations did I have at the very, very beginning? Two. And I also made this third one, right? Yeah. What am I missing? I have a y value, so what am I missing? An x value. X equals this. Y equals 2. What's that? So if I had x equals 4y minus 1, and I had that highlighted in orange, what would I do? Substitute what? X would equal 4 times 2 minus 1. What's 4 times 2? 8 minus 1. What's 8 minus 1? 7. Meaning my x value is now 7. Now, do I have an x and a y? What are they? So how do I write that in math class? 7, 2 to make an ordered pair, right? While we wait for my computer to work again, are we sure that it's 7 and 2? You guys are that confident in your algebra? That's funny, because every time I ask you to do algebra, I sit here waiting 20 minutes while somebody says, move the 3? What should you do, Jack? You should check. That way you don't have to say, Mr. Myers, am I doing this right? Because that 7 is what? An x. That 2 is what? What letter is that? X. What letter is that? Y. Is 7 minus 4 times 2, which is 8. Is 7 minus 8 negative 1? Yes. Is 3 times 7 is what? What's 5 times 2? Is 21 plus 10 31? So did you do it right? So do you need to ask me? No. Is it worth 1 second to check? Yes. Everybody got it? That's how easy this is. Let's look at the next question. What letter are we going to work with for the yellow? Let's choose it. Top equation or bottom equation? Top equation. Why? Because y is by itself. So my job then is to take that and get y by itself. What will it be? Okay. Y equals negative 2x plus 3. Excellent. What is the next thing we do? Now I've got my blue. Where does it go? Into the second equation. The second equation was 4x plus 3 what? Right. It's not y anymore because we just found out what y was. What does that equal? 1. There's my blue step. What do I do with that? I expand the brackets. In order to do what, Brianna? What's my end goal with this blue-lined equation? To get x by itself. So let's do our math. 4x plus 3 times negative 2. What's that really? Right. So I'm going to write plus negative 6x. What's 3 times 3? 9 equals 1. Why am I hearing what the? What is 4 plus negative 6x? Negative 2x plus 9 equals 1. Now what? I'm going to bring the 9 over, or I'm going to subtract 9. Whatever you do when you do algebra. So negative 2x is going to equal what? Negative 8. Then what? Divide both sides by negative 2. And what is x going to be? 4. Now there is my finish of the blue. Now what? I think I might have lost my colors here. Oh, yeah, I did. This should have all been the green stuff. Whatever. You guys don't need the colors anymore. You're smart. So that is going where? So what does y equal? Negative 2 times what? 4 plus 3. What's negative 2 times 4? Negative 8. Plus 3 is? Negative 5. So y equals negative 5. So what is my ordered pair?
Negative 5.
Nope.
4.
4.
And negative 5.
Are we right? Let's check. What's 2 times 4? What's 8 minus 5? 3. Are we right? Yep. What's 4 times 5?
20.
Sorry, 4 times 4.
16.
What's 3 times 5?
Negative 15.
Negative 15. What's 16 minus 15?
1.
So are we right?
Yes.
What, Nick?
On the first one, you put 5 on the right, and then it doesn't matter why you put it 3 y.
I'm sorry, Nick, I lost you because somebody was snapping fingers. I had you up to, in the first one, you did something on the left. Okay. Everybody cool?
Yes.
Okay, let's look at this one and tell me what's different. Jack. There's no one coefficient. But what do you see here? They're both the same, aren't they?
Yes.
So what would happen if I moved that over there? What would I get? 4x equals negative 5y plus 2, correct? Does everyone agree with that statement? All right. As soon as it shows up, I'll go further. What do you see right there that is now green? 4x. What do we know that 4x is? So what can I write there instead of 4x? Negative 5y plus 2 minus what? 20y equals what? Then what would you do with that? What you already know. What would you do? Negative 5 minus 20 is? Negative 25y plus 2 equals negative 3. Now what? Negative 25y equals negative 5. And what does y equal? 1/5. Why was that way too fast? Because you're talking to TJ and playing around and doing stuff that you're not supposed to be doing. I have eyes and ears. Okay. Without speaking at all. Okay. What?
I wrote mine in graph, but I did the 4 and like took the other 4 of the equation. So I just like to multiply around.
I'm sorry, you did what?
I like when you did the 4x, because I used 4x, I like to multiply mine by 4 in the brackets, so negative 5y plus 2.
But Brianna, that's not going to help you. Because these didn't have a 1, I couldn't do the same substitution. This is a different situation. So we're going to use the concept. The concept was we can change these around so they look similar. So what I did was I moved this 5y over here. Are you okay with that? Now please notice, 4x equals that. The whole thing, not just x, 4x equals that. So down here, I had a 4x. So instead of writing 4x, I wrote the negative 5y plus 2. I don't need to multiply it because negative 5y plus 2 equals 4x. So it was already multiplied for me. And then I kept the 20y. Then all I did was the same algebra we've been doing forever. If you still cannot keep up with this algebra, I'm not talking to you right now, I'm talking to everyone. If you can't keep up with this algebra, what do you need to do? Work on it. Because this is the algebra you learned in the 7th grade. And I cannot continue to stop everything to review how to do algebra for you. All right? When you learn to drive, no one is going to stop and remind you of how to go forward. Okay, push down on the gas slowly. They're going to expect you remember that from the first lesson. Aight? Now, what do I have there? I have what y equals, correct? Everyone agree? Okay. Well, how am I going to find what x is? Where can I put that answer? Anywhere I see a y. Anywhere. Could I put it in here? Could I put it in here? Could I put it in here? Would it matter? No. Which one do you want to use? You want to use this one? Okay, let's do that one. Watch what happens. 4x equals negative 5. What's y? 1 over 5 plus 2. What happens to these two 5s? They cancel, and I'm left with negative 1 plus 2, right? Okay. And this side is still 4x. What do I do with negative 1 and 2? Add them to get 1. What do I do with this 4? Divide it. So what will x equal? 1/4. Am I done? Do I have an x and a y?
Yes.
Excellent. They are 1/4 and 1/5. What should I do with that? Check. The x is 1/4. What is 4 times 1/4? 1. The y is 1/5. What is 5 times 1/5? What is 1 plus 1? 2. Are we right? So far, what is 4 times 1/4? 1. What is 20 times 1/5? 4. What is 1 minus 4? Is it negative 3? So are we right? Yes. Is everybody good? What was the new thing you learned today? That's the new concept. Did you learn any new math?
No.
Was there anything today that you did not already know?
No.
No. Nothing. So, you guys are going to take about 10 minutes or so to work on these 8 questions that are on your next page, 234. The answers are all at the bottom. You can check it. Do them. And do not think that the lesson is over, because we're going on to something right afterwards. Because there's 2 ways to solve systems exactly. One is substitution, which you just learned. The other one is different. Elimination. And it has certain times when it's a better choice than substitution. Yep. When you see elimination, half of you are going to say, why didn't you teach us that first? I like it better. And then the other years that I teach elimination first, half the kids go, why didn't you teach us substitution? Substitution's better. So now I don't care. I just do whatever I feel like. Yes. Is there any one of these 8 questions that anyone would like me to go through? Like you did it once or twice and you're like, blah, I still can't get that answer at the bottom. 5A. All right. 2x plus 3y equals 11 and 4x minus y equals negative 13. Is there a letter there that is alone? Which one? Y. So if I move this y over here, and I then move that 13 over here, what am I going to have? Oh, sorry, guys. No. If I move that y over here and I move that 13 over here, what am I going to end up with? 4x plus 13 equals what? Y. Is y now by itself? So what can I do with all of that everywhere I see a y? I can substitute it. So what will I get here? 2x plus 3, 4x plus 13 equals what? 11. And then I just do algebra. Can I leave you at the algebra, Sam?
I screwed up after that part.
Okay, so we'll carry on. 2x plus what's 3 times 4x? 12x. Plus what's 3 times 13? 39.
It's not 13.
Of course it isn't 13, it's 39. Because 3 times 13 is 39.
I can't read. I understand.
All right. All right.
Are you going to your Zen place, Mr. Myers?
No, because in my Zen place, there's people that can multiply. And there appear to be few of them around.
What about people that can spell? Hey, Jack.
All right. Everyone's good? Okay. You need to turn a couple of pages hence until you get to the page that says solving by elimination. Don't worry about that puzzle sheet. We'll come back to it later. Everybody put an axis on this sheet somewhere. If I wanted you to solve this by graphing, what would you do? You would solve it by graphing. And we did that the very first thing we did today. We'd slope-intercept form. 3y equals negative 4x. So y equals negative 4/3 x with no y-intercept. So I put it at 0, 0. Yes? And then I do a slope of negative 4/3. Down 1, 2, 3, 4. And right 1, 2, 3. Down 1, 2, 3, 4. And right 1, 2, 3. And I would make this line. Is everybody cool? Okay. Then I would do the same thing with the blue. Negative 3y would equal negative 5x plus 27. Then I would divide everything by 3, and I would get y equal positive 5/3 x minus 9. Then I would go down to negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I would go up 1, 2, 3, 4, 5, and over 1, 2, 3, and I would see I cross right there. Is everyone cool with that? Please notice that I'm going back to graphing because it's going to help me explain how this method works. Is everybody cool with that? Did I cross at an exact point? Yes? So graphing is okay here. Agreed? And what is the solution then to this system? What is the coordinates of that point? 3 and -4. And we're good. Yes? Right? Okay. Now, the next thing says pick a number. Please do not say it out loud. Please do not pick a number greater than 10. Please do not pick 1. Everybody got the number in their head?
No, less
No.
than 10.
Between 2 and 10. Everybody's got the number in their head? Now, take that number that you have in your head and multiply this equation by the number that is in your head. So I am going to use 3. You use whatever you want. You may need to use your calculator. Just do this. That is going to get me 15x minus 9y equals, no, 27 times 3, dude. 81. Has everybody done their multiplying? Now, I would like for you to take your equation, whatever you got, and solve for y. And what do you notice?
It's the same thing.
What do you see highlighted in green? They're the same line, yes? So what do we notice? So what does that tell us about multiplying both sides of an equation?
Makes it easier. Well, no.
It made the numbers bigger. You guys have trouble with bigger numbers. What did it result in? The exact same line, right? So, will multiplying either equation change our solution? No. So multiplying both sides of a linear equation results in another equation that still has the same solution. So what does it really do? It allows us to change the appearance. And only the appearance. Okay? Everybody understand? It will look different, but it will perform the same mathematically. Everybody cool? All right. Turn the page over. I am asking you to add these equations. So if I'm going to add these equations, I have x's, y's, and constants. Do they have to stay with each other? Yes. So add the x's. How many x's do I have there? 9 x's. How many y's do I have there? 0, because 3 minus 3 is 0. And how many constants do I have there? 27. Right? Now, what happened? Y disappeared. Correct? We eliminated right? Everyone agree? We're not going to bother graphing it on the grid above. We're just going to work with what we just did. So now the y variable is eliminated, right? Think back to substitution. Why did we have to do substitution? To figure out how to get the solution, because there were 2 variables, right? What did we just do? Got rid of a variable. So now we could solve this, couldn't we? Because now we're missing, we don't have 2 variables. Everybody good? All right, so now let's subtract them. What happens? What's 4 minus 5? Negative x. And what's 3 minus 3? Plus 6y. And what's 0 minus 27? Negative 27. Look at that. Now you guys are smart kids. When we did this, what would be your next idea with this? What do you think mathematically we should do? Pardon me? Divide by 9. So x would equal 3, correct?
Yes.
Okay. Now if we were, you guys don't have to do this, just watch. If I go back to this graph and I put x equals 3 on it, doesn't it go right through the solution? It does. Now the other line we just made was this one. Negative x plus 6y equals negative 27. Don't bother doing this, just watch. What would you want to do to put that on this graph? Get y by itself. So 6y would equal x minus 27, right? Y would equal 1/6 x minus 27 over 6, which is 9 over 2, which is 4.5, correct? Watch. 1, 2, 3, 4.5. Everybody agree that that's my intercept? Okay. 1 rise would go to there, and then 1, 2, 3, 4, 5, 6 would go to there, correct? What's going to happen when I connect those black dots? I'm going to go right through that center again, aren't I? So, multiplying, dividing, adding, subtracting, all allows us to change the way the equations look. But do they change our solution? No. If I can change the way something looks, can I make it easier to work with? Yes. Let's do that. So, adding or subtracting. What happened when I added or subtracted? I was able to do 2 things. What was I able to do? I was able to, it results in a third equation which has eliminated one of our variables. You have no idea how hard it is to write that long a sentence and not have anything showing up on my screen. Not bad, though. Now, in this case, which one was the smart one to do? Add or subtract? Add. So we add when what? What situation here made adding the good decision? I had a +3 and a -3, so it makes sense to add them. Add when the coefficients have what kind of sign? Yes, when the coefficients have opposite signs. What do you think you should do if they're the same sign? Subtract when they are the same. So, let's look at this very first situation. Do you see? Oh, actually, no, not yet, not yet. What is one way that I could write a third equation there that will work for me? What is one thing I could do? I could add the two equations together, couldn't I? What's another thing I could do? Subtract the two equations. What's another thing I could do? Multiply which equation? Either one you want. By what number? Whatever you want. Everybody cool with that? Everybody understand? All right. Now, turn the page over and let's put all of this into practice. Look at the first system. Please notice I've given you all the steps. Look at the first system. Do I have any coefficients that are the same number? Where? 5y and -5y. Are they the same sign or opposite signs? Opposite signs. So what should I do? Add or subtract? Add. So if I add those up, what do I get? 7x equals 14. So what does x equal? 2. When x equals 2, what does that mean I could write there if I wanted? What about there? Would it matter which one I used? No. Which one do you want to use? The first one? Let's use the first one. So it's not 3x. What is it now? 3 times 2 minus 5y equals -9. What's 3 times 2? Minus 5y equals -9. What's your next step there? Get y alone. So what are you going to do? You're going to take 6 away from both sides. -5y is going to equal -15. Now what? So y is going to equal what? 3. Now you guys are smart kids. What is my ordered pair now? 2, 3. Which equation did we check this in? The top one or the bottom one? We used the top one. Should I check the bottom one just to make sure? What's 4 times 2? What's 5 times 3? Is 8 plus 15 23? So can we do math? Yep. Everybody cool? All right. How many people like elimination better than substitution?
I have no preference. I just don't like drafting.
All right. Now, read this. Read this. Everybody reading it? Good. Look at this first set. Is there a coefficient that is the same number? No. So I have to change the way they look, don't they? Multiply. What should I multiply? What is one choice I could make? If I multiply the top one by 2, what would I get? 2x minus 4y equals 14. Does that put us in a position to do elimination? Excellent. Now stop for a second. Could I also, if I wanted to, have multiplied this by negative 3? Why? Because then the x would work. And it's up to me to choose. But since everybody said to do 2, we'll do 2. 2x minus 4y equals 14. Are they the same number?
Yes.
Are they different signs?
Yes.
So is it add or subtract?
Add.
Add. What's 3 plus 2? 5x. What's 1 plus 14? What does x equal? 3. If x equals 3, where can I put it? Any x I see. So how about 3 minus 2y equals 7? Would that work? Okay, what would you do next? Would equal 4, and y would equal negative 2. What is my ordered pair? 3 and negative 2. Should I check it?
Yes.
I already know it works in the top equation, so I just got to check the bottom equation. What's 3 times 3?
9.
What's 4 times negative 2?
Negative 8.
What's 9 and negative 8?
1.
And that's what it's supposed to be. Now look at the third one and tell me what's going on. I got to multiply both because neither one is pretty, right?
Multiply 1 by 3 and 1 by 2.
Excellent. If I multiply this guy by 3 and this guy by 2, what am I going to get? 6x. Sorry, other way around. If I multiply this guy by 2 and this guy by 3, I'm going to get 4x minus 6y equals 40. And what am I going to get down here? 33x plus 6y equals negative 3. Now what can I do? Add them. Why are we able to add them? Because the 6's are opposites. What's 4 plus 33? What's 40 minus 3? What does x equal? 1. What do I do now? Plug it in where? Any x I see. I'm going to do the bottom x. 11 times 1 plus 2y equals negative 1. 11 plus 2y equals negative 1. 2y equals what? I got to subtract 11 from both sides, so it's negative 12. And what does y equal? Negative 6. So what's my ordered pair? 1 and negative 6. We know it works in the bottom one. Let's check it in the top. What's 2 times 1? 2. What is negative 3 times negative 6? Positive 18. What's 2 plus 18? And doesn't it need to be 20? Is everybody good? All right, now I want to do something a little, I want you to do one more, but you don't have to do it. I just want you to see it. Because you've noticed both these times we've been able to add, right? What if I gave you something like this? It's going to say 5y. y equals 23. Everybody cool? And 3x. What would you do here? Would you add? Why? There's no opposite sign, so I'd subtract, right? What's 3 take away 3? I'm getting to that. 0. What's 5 minus 2? 7y. And what's 23 minus 5? 28. And y would equal 4. Everybody see how the subtraction one works? You got to be careful if you're going to subtract. Because when you have minus minus, it becomes positive. Is everybody good? All right. Try some of those. Now listen, if you want extra practice, and I know none of you do, there's 2 puzzle sheets here that are funny jokes.
That was Donald Trump. Why does the president put his vegetables in the blender? I don't get it.
Because you haven't done the work. When you do the work, the answer will be revealed.
Is it a pun?
Yes, of course it's a pun. That's hurtful, dude.
I don't like puns, I'm sorry. You could like read it really slowly or something.
Did you hear about
Now, listen up, please. I'm assuming that we're all done here. You've got the answers. You're going to finish the day working on it. Obviously, we're going to have a little bit of extra time. So I'll go over a couple of these before the end of the period, especially some of the ones that have not X's and Y's, because for some reason you guys have trouble with that. Now,